First of all, I suppose we need to kind of review here, and if you need to write this down, please do. When you talk about transformations, we have like three main things, and then we have a couple other things that we talk about when we talk transformation. Transformation just means how things change or move. Actually, more about moving. And we have three different ones. You'll remember these. They are, remember there's the rotation. Another one is the reflection. And the third one is a translation, which just means, translation just simply means it slides. Rotation or reflection means it's a mirror image. And rotation means it spins. And then we have, kind of on the other side, we have contractions and dilations. We don't talk a whole lot about the dilation. A dilation means it gets bigger, and contraction means it gets smaller. But when you talk about contractions and dilations, you're talking about it stays proportional though when it does it. But that, I don't think we talked too much about that, but it's good to know. So we are going to look at how that works when you talk about grids, because it can be kind of confusing. But if you kind of think about it, and there's no easy like formula, I can't really, I mean, I can give you kind of the pointers as to how it works and what to think about, but I can't really nail down a set of directions. For example, this one, if I am rotating, this bad boy right here, if I am rotating that, first of all, 90 degrees, which means what? A quarter of a turn, correct? Okay, you got to get that. Counterclockwise, which some people have trouble with, the clock turns this way, so counterclockwise turns this way. That's counterclockwise. About the origin. Okay? So basically that means this, and I can kind of draw you pictures of it, but okay, here's my shape. I am spinning it. This is the deal. Okay? If you could lay a piece of paper over top of this and trace this triangle right here, I don't want to draw over top of it again, and then put a pin in your paper at the origin, and then turn the top piece of paper a quarter of a turn, where would it end up? How would this triangle look? Where would it go to? Okay? And I can tell you, this is probably the easiest way to do about it. You're doing a 90-degree turn, which means what really happens is this axis here, correct? The x-axis actually turns 90 degrees and becomes the y-axis there. So this point here is 1, 2, 3, 4 there. If you spin it, it's going to end up being 1, 2, 3, 4 here. This z will be z prime right there. Same thing with this. Wait, is that the letter z? What is this letter here? L? This point here, it's going to go 1/4 of a turn, so this, the y-axis, would actually end up being the x-axis right here, and point L will be 1, 2, 3, 1, 2, 3 away from that point. We'll call it L prime. So I have my z and I have my L. Where will this point be? How would you figure out where this point is? Well, kind of along the same lines. Here's your x-axis, and it's 2 down from your x-axis, right? If you take that and rotate it 90 degrees, it's still going to be 2 away from that axis. So it's going to end up being right here. So there's my j prime. Now you can just connect your points. This point here, and this point here, and you have the 90-degree counterclockwise movement of that thing. I would suppose in worst case scenarios you could actually take a piece of paper, set it over top of it, trace it, stick your pencil in there and spin it and see where it looks like it ends up falling on there. I mean, you could actually kind of cheat on it too, probably, and do it. But this is where your rotation would end up. Like I said, there's no There's no magic formula for this. It's all kind of, you just kind of got to take some clues and kind of figure it out based on where your axes are. Ain't that exceptionally exciting? Now, rotations and reflections are by far a lot harder than translations, because translations, they're pretty cut and dry. Whatever that is. Why do we use cut and dried? What's it in reference of? Anybody know?
Vegetables.
Do you cut, do you dry vegetables? Not really.
If you steam them, try to.
That's dehydrated. But first of all, if you steam them, you're actually rehydrating them. Dehydrating them.
Wood.
Huh?
Wood.
You do cut and dry wood. Probably a good one. Translations, on the other hand, ladies and gentlemen, are very easy. This translation is 4 units right and 1 unit down. So you just pick a point. Here's point F. Go 4 units right, 1, 2, 3, 4, and 1 unit down, and you just label that as point F prime. Point G, 1, 2, 3, 4 units right, 1 unit down. Point Y, 1, 2, 3, 4 units right, 1 unit down. And then you have whatever shape it is that you have. Translations are by far the easiest thing. Reflections and rotations are much, did I say much? I'm sorry, I meant much more difficult. That's a pretty simple one right there. Let's do the reflection one. When you do reflections, the first thing you have to know is what you're reflecting about. And the reflection here is the x-axis. And you probably should highlight that. Okay, so here is my reflection point. Okay, and the second thing I would think about is think perpendicular. And sketch it out 1 point at a time. Okay, let me give you a second. Give you a second to process this. I'm going to do my reflection in blue just because I don't know why I like blue. Okay, this is my reflection point or my mirror point. In other words, you have to think about if you folded the piece of paper, how would it match up? So if I am looking for C prime, my new C point, this is my reflection point. It's 1 unit up from there, so I do the opposite or go perpendicular to that and go 1 unit down. Here is my new C prime point. Same thing for J. From my point of reflection or my line of reflection, it's 1 up, so I go opposite, go 1 down. It's J prime. So now this line between those two is actually this line right here. Finding the new point K. Again, look at it with respect to where your reflection point is. K is 1, 2, 3, 4 down. So go 1, 2, 3, 4 up, and there is K prime. M, from this point right here, is 2 down this way. So you go 2 up this way, and there is point M prime. Now you can just connect your points. These guys connect right here. You know, this comes down here, connects right there. That connects right there. And again, if you took that piece of paper and folded it over top of each other, that's what it would look like. Ain't that neato schmeato? Usually people gasp in amazement at this. That's gasping in horror. Amazement is something different. Do this one for me, because you can do this one. Give me a translation that's 1 unit right and 1 unit up. 1 unit right, 1 unit up from there. One unit right, 1 unit up. You should be about done. Look at Tyler. Bam! And again, you please label it. You should have points T prime, M prime, E prime, and J prime labeled. It's just the smart thing for you to do as young 7th graders in the prime of your mathematical careers. And what would that look like? Let's just take the quick, short, easy route here if I can snag this thing. 1 up puts it right there, and 1 right puts it right there. That would be your new M prime, E prime, J prime, and whatever this letter was, D prime. Everybody get that? Everybody happy? All right, let's do a harder one. What's this one down here? Oh, is this? What rule describes that transformation? What rule is it? Jacob?
1 unit right.
Yeah, what type of move though is it? It's a translation. Translation, 1 unit right. Next one, not so easy. How about that one? Obviously, it's not a translation. Doesn't, to me, look like a rotation either because the shape is kind of changed around. You'd have to tell me what it is and where it is, and why it is, and why it should be right there. Carter A says it is a, first of all, what type of?
Reflection.
It is a reflection. And what is it reflected on?
The y-axis.
Well, it's not on the y-axis because that would be a reflection on this point right here. It is a y line. Which y line is it?
1.
Well, actually, it's not a y line. Oh yeah, no it isn't. Yes it is, no it isn't. Right here's your reflection point, right?
Oh, 3.
And it is actually where x is 3. It's a reflection on, I believe that's the, wait, let me see, hold on a second, let me see how they label it here. Let me see if I have the actual answer here. Make sure I get this right because some days are diamonds, some days are stones. Yeah. The reflection of that is actually where x is 3, because this is the point where x is 3. So right there where x is 3. If it was reflected on the x-axis, that's actually where y is 0. It's reflected on one of these lines where x is 3. Reflection on x equals 3. Woo! Excited about that. Next page. Ooh. Oh, what's number 7? What kind of transformation is el número el cinco? Let's find this. Cinco, seis, siete.
7.
Wait, it is a,
Reflection.
about what?
The x-axis.
Yeah, reflection on the x-axis. Because here's your middle that cuts it right in half and it's flipped over there. And this one over here is a, now be careful with this. You might want to say it's a translation, but it is not. That is not one translation. You probably could give a couple different answers. Abram says it's a,
Reflection.
it is not. I don't believe it's a reflection. Now, here, Abram, and this might help you here, because if you said it was a reflection, you're saying it's probably reflected on this line right here, right? Correct? Which would be true for these 2 points, except, see this G? It doesn't match up with the G prime over there. Neither would this. If you did a right angle here, this X would end up over here, not over there. So reflection, while it looks like a reflection, is not it. Goss, what do you think?
Rotation.
I'm going to go yes, rotation, but now comes the tough part. What is the rotation? First of all, about what point is it rotated? What would be the middle point of all this? If you drew lines between all these points, where do they cross?
Origin.
Right here. So it's a reflection about the origin, but now you got to tell how many degrees around the origin. How much would you have to spin this around the origin to get B from here to here? How many degrees is that? Tyler?
180.
Yeah, it's a 180 degree rotation about the origin. Because notice how this line, here is here, I could actually do it. I think I have the capability, children, with modern technology here. There is my origin, my new B prime. Oh, that's not it. Can I spin it? If you go 180 degrees, went from there down to there, 180 degrees. Beautiful, Griswold, just beautiful. All right. Nine and 10, I'm going to give you, about 4 minutes to try number 9. First thing is you have to do is you have to plot these points. You're going to get B, C, Z, and X. And then after you plot it, you are going to rotate it 90 degrees about that origin there. On your mark, get set. First one done wins the grand prize. I'm going to think about it right now. See what you get there. Again, I would strongly encourage the use of straight drawing lines. And you may not, this would be the one in a few times on homework assignments or something like this that I would say using a different colored pen might actually be a good advantage for you. Just because sometimes pencil is a little hard to distinguish. Meanwhile, I'll be right back. 30 seconds or less.
This is very nice.
I don't like the rotation and reflection. I don't like it. I like the translation.
I think I got it.
The easy one.
Getting it.
I'm looking at it.
I'm not even done. Oh, I ruined it. Oh, I ruined it. So I like, what's a different colored pen? What's the trick?
Oh, I
I think I got it. I think I got it.
I
think I have it.
I haven't
I
started on the
I have
rotation.
it. I'm not showing you. I'm not even do. Let me see.
Well, you know, let's see here. If we just take a wild guess.
No, it's about the origin. Shoot.
Hold
on. Who has a different piece of paper? No. Say I did it.
No.
I did 180.
I can't. Just take it.
It goes off the graph, doesn't it? No, it doesn't.
No, it doesn't. Take it like this.
This way.
It's
It's
actually
actually
like
the actual, you know what I mean? What's pretty good?
Oh, completo?
Yeah.
Turn to 0. And again, you should be labeling these. C is -4, 3. 1, 2, 3, 4, 1, 2, 3. Right? Z is -3, 4. -1, 2, 3, 1, 2, 3, 4. And X is -1, 4. -1, 2, 3, 4. You get some sort of goofy looking shape as such.
Goofy goober.
Right? You got that? So, here's what you do. We're going 90 degrees clockwise, which means this Y actually ends up being this X. So, this point, this X is 1 to the left. So if you spin it, it's going to be 1 to the left right there. That is your X prime. This axis right here will end up being this axis, and if this B is 2 away there, it's going to be 2 away there and B right here. That is B prime. This C, you can look at it either way. C is over 1, 2, 3, 4, and up 1, 2, 3, so it'll be, when you flip it over here, 1, 2, 3, 4, up 1, 2, 3. There's C prime. Z, you could just think of it being here, up over 1, 2, 3, 4, and then 1, 2, 3 left, 1, 2, 3, 4, 1, 2, 3 left. And there is all of my points. My new shape looks the same way, just rotated about that axis.
I did it counterclockwise.
Same.
I was a
People need the Lord.
I did that originally. I did it. Or is the old one?
Okay, go ahead, try the reflection. Now, here is the deal. Listen carefully. Look. The reflection is y equals x, which means the y-axis then becomes the x-axis. Technically, I would imagine really the only thing you need to do that reflection is maybe flip-flop those numbers. If y equals x, then x equals y.
so
Reflection across y equals x. I'm actually going to guess that this means that this is going to be a reflection point. It'll be interesting to see what you come up with that. -5, -2. Which means +2. -5. This is where, ladies and gentlemen, we need to have the answer. Where is that? Which one is it? Next page.
right side.
This one?
Yeah.
Y equals x. Yeah, that's your reflection point. Don't flip flop the numbers. It's actually, it's this. This is your reflection point. That's what you're going to reflect it about. That little diagonal line. So you just have to remember this point here is 2 points that way. So the new point will be 2 points that way. Same distance, perpendicular. Wait, did I do that perpendicularly wrong? Draw a perpendicular line. Actually, I think it'll be right here. I think that's wrong. Maybe I'll do the first one and then we'll talk about it. Let's do this. That one's a tough one for all intents and purposes. -4, 1. 0, -1. -2, 4. K, A, I. 0, -1 is right here. Oh boy, -4. Faith, you should go. No sign. Make sure I get this thing right here. Your shape look like this?
Yeah.
Wait, no, it doesn't.
Oh yeah, that's my shape.
Mine
does.
Mine does.
My shape.
But how do you rotate?
Nope, it's reflected. Now watch, this is how this would work. And granted, this is a pretty tough one. Here's what you should be thinking of. Let's take a look. Remember, this diagonal, that diagonal is our reflection point. So it's really easy to do perpendicular lines to that because all the perpendicular lines are going to split these diagonals right down the middle, like this. So if I'm looking for this new point right here, see where these cross right here? You go doop doop there, it's going to end up being right here. This is K prime. This point right here, you look at the point of reflection, is just one diagonal away. So the new point is going to be right here, which is what was that point? J prime. This is J and J prime.
You could have just rotated the numbers. That's what I'm getting right now. That's what I did.
Rotating won't work.
Or like switching the numbers because it's like -2, -5. That's what I did. And then it's
Yeah, but if I flip these around, I get -4, -2, -4, oh, maybe it does work.
Wait, so I get first. What number?
Would -2, -5 work for this? -2, -5, I think it does work. Y equals X. Good call, Abram. I said that, but I didn't think it worked when I tried it.
You didn't beat this one.
Well, he said it.
He said it. You said it.
I did say it, but then I tried it and I didn't think it would work. But 0, -1 means -1, 0. Yep, that works for this point. And 1, -4. Oh, I already did that one. Well, I don't want -4 works for this point. Is that right?
That's not one of
Oh, 1, -4, sorry, right here. So this is your new shape. You're here, here. Shabam.
Shabam. Where's all that dough?
Oh, yeah.
So you have 10 minutes. Wait, without looking at them. Gauss, 11, 12, 13, 14, pick 2.
Yes.
Pick 2, quick.
12 and 14.
12 and 14, those are your assignments. You're gonna need some people to grab paper somewhere.
Why the reflection? Why?
Because she wanted a challenge, that's why.
No!